Okay, the other part I want to briefly mention is the chapter 8 talking about the frictions. Okay, you already know from college physics, I think like physics 7C or something, no matter what you learn, even in high school. Frictions are everywhere, basically, right? So many of them are bad, but many of them are good as well. So that's why we say the friction is both problematic, but also sometimes it's very useful in many engineering applications. Okay, for example, you have this kind of a brake when you ride a bike, or you have this space shuttle. This is a launching or a landing, I don't know. Anyway, there's a friction related. Typically, when we talk about simplified engineering problems, when you have a block on the surface, okay, so if there's no horizontal forces, there's no friction needed. Okay, however, once you apply a tiny force in the horizontal direction, then obviously there will be a friction. Okay, assuming the surface is now smooth, right? So now, typically, when you keep increasing the P, then the friction will increase. The friction will increase. So in the static scenario, the friction would increase until it reaches the maximum. Then this one starts to move. Once this block starts to move to the right, then this is called a kinematic, right? Kinetic friction force will be a constant. Before its movement, the friction force resistance keeps increasing until it reaches the maximum. The maximum can be calculated with this, what we call the static friction force maximum, multiplied with the pressure, which is called the use N, this N, right? Okay. And once it moves, you are no longer having the static friction force. Instead, you're going to have a kinetic friction force because it's moved. So then, this friction force is equal to coefficient of friction multiplied with N. But these are all you learn. I don't want to talk about this. Today, I want to talk about one more thing which you might learn, you might not learn. And the reason I want to point out this one is simple, but this many times for those civil engineering students, when you become a senior student, most likely you're going to take what we call the EIT test. And this is the part of the EIT test. Now, typically, you may encounter one simple example just to use that equation I'm going to show you to calculate something. You see, in many engineering practice, for example, you use this kind of cables, right? You use this kind of cables, okay, belt. This is called a belt friction, which is not part of this, because you learned this one, I know. But if you are talking about something like this, to control a big boat or a ship using this one, obviously from common sense, the more circles with this belt, the better, because it gives you more friction. But you may say, how much? Right? If you want to quantify the friction, then this is something we need to deal with. Okay? And sometimes you see when you're trying to hand on a crane, for example, you may have more circles with this cable to increase the friction. Okay? The bottom line is, once you have a belt passing through a circle, a wheel, or a pulley, for example, then you need to know how to calculate the friction between this contacting angle, which is totally called beta. It's called beta, right? Called beta. Okay? So in other words, if you ignore the friction, then T2 is always equal to T1 because there's no friction. But if you do need to consider the friction, then T2 is not equal to T1. But which one is bigger? It depends on which tendency this will try to rotate. So if you're trying to rotate to the right, then T2 will be bigger than T1 because you have to overcome the friction. Okay, and this is the general scenario I want to talk about, and to finally give you this equation between T1 and the T2. Okay, so anytime when you are dealing with any of this kind of problem, as long as you have this equation, you can quantify the friction force. You may say, wow, wait a second, this is only I'm talking about something with a beta less than 180 degrees. Now I'm talking about this one. What kind of angle we need to say? One circle is 360. If you have two circles, then what? Times 2. You have 3 circles times 3. And you have a 3 circle and a little bit more, then 3 times 360, and then plus another angle, 30 degree, 50 degree, whatever. Okay, so that's why the more circles you use the cable, the better, because you provide with more friction. Okay, so back to this one. We are trying to use a relative simple statics because this is the static course, right, to derive this equation. Same thing, we basically use those equations, okay? So let's say we have this scenario with a T2 going this way, T1 going this way, T2 going that way. But you need to know it is about to slide to which direction. So if we assume we want to relate T1 and T2 when the belt is about to slide to the right. So it's about to the right, then T2 need to overcome not only T1 but also the friction. So obviously T2 is bigger. Okay? Because T2 should be equal to T1 plus this kind of friction resistance. The bottom line is how we can get this equation. That's a typical we do by making a very small cut on the top. And then we do the integration. And then we solve the problem. Making this small cut with a delta theta. That angle is very small. You have this part, belt. And then we have a T. And we have an additional T. So this additional T is T plus delta T, which is kind of overcoming the friction part. So delta T, or say, I'm sorry, this T prime is T plus delta T, the increment. In addition, at this point, there is a reaction because of the wheel. You call this delta N. And there's a friction here, right? It's very small. We just assume the friction is horizontal. Later we'll do the integration. So this friction equal to the normal force multiplied with the friction coefficient called the mu s times delta n. So this is what we call the free body diagram. What you need to do is to collect all the forces in x direction and set equal 0. You need to collect all the forces in y direction and set equal 0. That's a typical static equations, right? You may say, what is the third equation? Which is the moment equation? Well, if this keep decreasing so that delta theta will be very small, then this part of the rigid body become a particle. So that's why you can still write down the moment equation, but it becomes a trivial equation, that's 0 equals 0. It doesn't work. So that's why you only need to use these two equations. From these two equations, you can just consider this very simple concept, in fact, right? You just collect all the x component together, all the y component together. Now, combining those two equations, you need to get rid of delta n first, because this delta n is something we don't need. So we want to build a relation between t and t prime. So from these two equations, combining them, you need to eliminate delta n, then you get this one. And then you need to keep delta theta smaller, 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 smaller until it reaches 0. Then it become delta t become dt, and the delta theta become d theta, and minus this one equal to 0 based on this equation. And this is a differential equation. You integrate out, then finally you get this one. So in other words, this log equation, you can get exponential equation, relation between t2 and t1. And this is not the equation I typically memorize. I would like to memorize this one, which is basically this. Because this is easier for us to memorize. This is the same thing with this one, but I just want you to somehow understand, in order to build a relation between this cable force and this cable force going through the friction belt friction case, then you need to measure this angle. Once you measure this angle, then you need to use the E exponential function, multiply the coefficient of friction, and multiply the angle beta. Well, they didn't draw beta. This is the beta. Or you still go back to look at the original picture. It's called beta. Okay? And then you can build a relation between these two cable forces. Okay? So typically, this is the equation you need to somehow know. Okay? In this textbook, we gave you this equation, but I'm not going to assign any homework, and I didn't talk about any examples. So this part and the cable part are obviously just for information. That's how I call them miscellaneous. Okay, but the strategy for solving such problem, I'm pretty sure you will use them in the later courses, especially for those of you who like to take this EIT test, or called the FE test, I believe now. It's called the Fundamentals of Engineering test. Typically, civil engineering students are taking it during your senior years. I do not know for mechanical aerospace, because civil engineering, they have a license requirement typically. If you want to do the consulting work after you graduate, you typically need to pass two tests. One is called the EIT test, and the other one is called the PE test. PE test, basically, you have to take it after you have several years working experience outside before you take the PE.